This is Algebra 2 with Trig, working on the review for 9.1, 9.4. Looking at probabilities. So you have an equally likely chance of choosing a number of 1 through 30 on a 30-sided die. We want to know what's the probability of an odd number is chosen. Well, odd numbers would be half of them. So the probability of an odd number would be any 15 of the 30 numbers, which is a half. And if we want to say a decimal, we can say a decimal. A perfect square is chosen. Well, the perfect squares, 1 would be considered a perfect square. 2 times 2 is 4. 9, 16, 25, 36 is over 30, so we only go to 30. So 1, 2, 3, 4, 5. So the probability of a perfect square was 5 out of 30, which is 1/6. You can do a decimal for that if you wish. And a multiple of 3. Well, a multiple of 3 is a multiple of 3. 6, 9, 12, 15, 18, 21, 24, 27, and 30. There are 10 of them. So the probability of a multiple of 3, let's use a little shorthand, is going to be 10 out of the 30, which can be reduced to 1/3. Here, these are disjoint. So if they're disjoint, then the probability of A or B is going to equal the probability of A plus the probability of B. There is no overlap, so there's nothing to subtract. So we're looking at 0.1 plus 0.45, so 0.55. That is the probability of A or B. Here, probability of A or B equals a probability of 1/2. Well, let's see. I'm going to change that up. One half plus 1/5. We need common denominators for that, which is going to make times this by 5, so 5 over 10 times this by 2, so 2 over 10. So we're going to be able to call this 7/10. Because there's nothing to subtract because there is no overlap. Now we have to determine if there's some overlap. So we're going to use our formula of probability of A or B equals probability of A plus the probability of B. That's just like if we're disjoint, but we're going to subtract any overlap just in case they have some same elements. So the OR, 0.25, probability of A, B, and we don't know if there's an AND. So 0.25 equals 59.59 minus the probability of A and B. We're going to subtract that across. So we get 0.25 minus 0.59, and we get negative 0.34, negative the probability of A and B. So this is going to be 0.34. So this shows overlap. So this is not disjoint. Here we can figure it out again. The OR is a fraction. The A is 5/8. The B is 1/4. Well, let's just make them all common denominators. So let's make them all a denominator of 8. So I have to times this one by 4. This one doesn't get changed. This one gets times by 2. So this becomes 7, and we subtract it across. And we divide that negative out of it, and we get 3/8. So this one has overlap because it has and. So is it disjoint? Is no. I know that before I even calculate it. The OR is 8/13. The A is 2/13. We don't know the probability of B minus the probability of and. Just like so. So these two put together, guess you could do that. -4 with a +2 is still a -2. And then we add that across. And that would be 10/13. We should be able to test this theory. Call it 2/13 plus 10/13 minus 4/13. And I'm expecting this to give us a crazy decimal, which is 8/13. And that was our OR. Perfect. So different ways that you can work on the problem. Okay, percentages. Well, we can work with percentages by moving the decimal spot. So we don't know if it has overlap yet. 0.52 is the OR. 0.17 plus 0.35 minus the probability of A and B. So that would be 40/52. So when we minus that across, look at what happens. They both cross off. So the probability of A and B isn't happening. So this is disjoint. Yes, it is, because we calculated the probability of A and B to be 0. Now we want to know about the sum being greater than 4. Well, here we have 1 plus 3, that's 4. 2 plus 2, that's 4. 3 plus 1, that's 4. We want to be a sum greater than 4. So one way we could do it is count where it is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and just keep going and count all the different ways. Favorable over possible. Okay? Another way to do it is the probability that we are 4 or less. Really a sum of 4 or less. So a sum of 4 or less is going to be 1, 2, 3, 4, 5, 6. That is 6 out of 36 possible. So the probability sum greater than 4 is going to be 100% minus our 6 over 36. Just a shortcut way, if you call it that. 6 goes in there 5 times, 6 goes into there 6 times. So if we know that there's 36 of them here, and we know that there are 6 that we're not looking for, then that means there are 30 that we are looking for. That must be greater than 4. How about a sum that's not 5 or 9? The sum is 5 or 9. Might be an easier way to do it. There's 1 of them, 2 of them, 3 of them, 4 of them. That's 4 out of the 36. And the 9, that's 9. That's 2 of them, 3 of them, 4 of them. So that's 8 out of 36. So probability sum neither 5 or 9 is going to be all of them. There's 36 different ways to have a sum, minus the 8. So that looks like it's 28 over 36. That's 14 over 18, half of that and half of that. So that's 7 over 9. We can test this. 28 divided by 36, we get the decimal of 0.7777, and 7 divided by 9 is also 7.7777. So either way we calculated it, it comes out the same. Of 120 students honored at a banquet, 40 won an award for mathematics, 55 for English. 14 students won for both math and English. One of the students is chosen at random to be in a newspaper article. What is the probability that the student that won an award in math or English? So one or the other. So the probability of math or English is going to equal the probability of math plus the probability of English minus the probability of math and English. Same formula we're using before. So out of 120 students, 40% won an award for math, 55 for English, 14 of the students won an award for both math and English. We got to be careful with this. It's not 14%. It's just 14 of the 120. So 14 of the 120 It's going to be a rounded number for us. Let's go with 14 out of 120. So this is 0.95. Minus our 14 out of 120. Showing our work. So just to make life easy, 0.95 minus 14 out of 120. And there we have it. We can turn that into a fraction pretty easily. It's 5/6. So we got 0.833, which is equal to 5/6. We could multiply that 0.95 by 120 to find out that it's 114 students, or in math and English, and then subtract that. That gives us 100 out of 120. And there it is. So either way you want to think about it, it works. The organizers of a potluck dinner send 6 people a list of 10 different recipes and ask each person to bring one of the items on the list. If all 6 people are randomly choose a recipe from the list, what is the probability that at least 2 bring the same thing? Okay, that would be a lot. We would have to calculate what's the probability of bringing 2 people bringing the same thing, and then 3 people bringing the same thing, 4 people bringing the same thing, 5 and 6 people all bringing the same thing. That would be a lot. So let's do the probability no repeats. No one brings the same thing. Okay? That means the first person can pick any of the 10 items. 10 out of the 10. The second person has to choose one of the items that wasn't the same. So that's the first person, can bring anything. The second, the third, the fourth, the fifth, the sixth. 9 different recipes they could choose from, 8 different recipes they could choose from, all the way down to 5 different recipes that they could choose from. So 10 times 9 times 8 times 7 times 6 times 5. Over 10 to the 6th power. Okay. Now we can start busting that thing down, or I'm not sure if this one will work here. That's our previous answer. Turn that into a fraction. And there's the most reduced version of that fraction. I showed all my work. That's 0. Okay. And we can even turn this into our decimal. I guess it would be exactly. Oh, that is no repeats, right? So if that's no repeats, the probability at least 2 repeats would be 1 minus 0.1512. So there's an 84% chance that someone's going to repeat. There's a 15% chance that nobody repeats. And we didn't take our time at figuring out 3, 4, 5, and 6. Adding those all together would give us this amount. These are independent of each other. So A is going to be 5/8 times 4/5. That's 20 over 40, which is 1/2. We multiply the probability of A times the probability of B. Here we know that the product is going to be 0.9 times the probability of B. So we divide, and we know that 9 goes into 54 6 times. So that's going to give us 0.6. If they are dependent, we know that the probability of A and B is going to be the probability of A times the probability of B given A. So we're looking for that. 0.15 equals the probability of A times 0.6. So we divide by 0.6. So the probability of A is going to be 0.15 divided by 0.6. That's 0.25. So our formula again is the probability of A and B equals the probability of A times the probability of B given A happened. So the AND is 0.27, the A is 0.3, and we're looking for the probability of B given A. So we divide out. And we see that that is going to be 9. 0.27 divided by 0.3, it's going to be 0.9. Let n be a randomly selected integer up to 20. What's the probability that the number is a prime number, given that it is even? So if we look at the even numbers, there are 10 even numbers. That we're looking at any of the even numbers. And the probability that it's prime, there's only one of them. The number 2 is a prime number. There is no other even number. So that is 1 out of 10. The number 2 would be a prime number. So is 3, so is 5, so is 7. Those are all prime numbers, but none of the other ones are even. N is 12, given that it is greater than 5. Numbers greater than 5. There are 15 numbers greater than 5, up to 20. So there's 15 numbers. The number is 12, given that it is greater than 5. So the probability, there's only one number, that is 12, that is greater than 5. There are 15 possible numbers. Find the probability you have a club, then a diamond. We're drawing 2 cards. We're going to do one with replacement and one without replacement. So a club with replacement, that's going to be 13 are clubs and 13 are diamonds. So 169, 13 times 13 is 169. And 52 times 52 is 2704. Turn that into a reduced fraction of 1/16. Now if we are going to keep the card out of the pile, we have 13 out of 52. We still will have 13 diamonds in there, but there will only be 51 cards. So that's 169. 52 times 51 is 2651, or 2652. And not quite sure that this one is reducible. There it is. 13 out of 204. A 5, then a face card, then an ace. A 5, well, there's 4 out of 52, and you want it to be a face card, 12 out of 52. Then the next card you want it to be an ace, which is 4 out of 52. Now we can reduce some of these. It's 1 out of 13 times 3 out of 13, and then 1 out of 13. Thirteen to the third power is 2197. This is 3 divided by 2197. And then 4 out of 52. That's a 5. Then a face card. None of those are 5s, but there's only 51 cards. Then an ace. Again, there's no overlap. There are 4 aces. None of those are face cards. None of those are 5s. We can do that a little larger. We can say just 4 times 12 times 4, 192. 52 times 51 times 50. And then we can see if we can reduce that. There it is. I'm showing all my calculations in here, showing my original and then my reduced. The calculator is helping me reduce. A king another king, and then a third king. (52 to the third power). So that would be 1 over 13 and 1 over 13 and 1 over 13. Okay, and then if we're not going to replace it, we'd have 4 cards out of the 52 are kings. Now there's only 3 cards out of the 51 that are kings. Then there's only 2 out of the 50 cards that are kings. So we got 24 divided by that previous number. Turn that into a fraction. It's an answer we've had before. 5525. So this is 1 out of 2197, and this is 1 out of 5525. Each drawer of a 5-drawer filing cabinet has 50 folders. You're searching for some information that is in one of these folders, but you don't know which one. What's the probability that it is in the first drawer you choose? Well, we could take a look at this and think about the 50 folders. So 50, 50, 50, 50. But really, it's all about the drawer that you pick. There's one correct drawer. There's one correct drawer out of the 5. It's not about the folders at all. Okay, last set here. You use the table to the right to find the following probabilities. A person chosen is a man who did not see a movie. Here we have the number of men, the number of women, the total number of people. We have people that saw a movie, people that did not see a movie, and the total people. So we have a person is chosen who is a man who did not see a movie, given they did not see a movie. If you only look at people who did not see a movie, that would be 39. out of 97. The person is a woman, given they did not see a movie. Okay, I'm going to come back up here to this one. This is a person chosen as a man who did not see a movie. Just a man that did not see a movie would have been 39 out of 160. It didn't say given we were only doing that. So a man that didn't see a movie would have been 39 out of all the people. There's your correct value. If you like the decimal idea, that's 0.244. Okay. Not that one. This one here, 58 divided by 97. That is approximately 0.598. A person saw a movie given it was a man. So we only look at the guys. We saw a movie. So that's 41. Given it was a male. So that's your 80. 41 over 80. That is approximately 0.5125, or that'll do. A person did not see a movie given that they were a woman. So if you just look at the ladies, did not see it, there we have it. Good luck, everybody. So just to re-explain what this table is, if I did that too fast for you. We have 160 people. We have 80 males and 80 females. Out of the 80 males, we have 41 of them saw a movie, 39 of them did not see a movie. Of the 80 females, 22 saw a movie, 58 did not see the movie. Of all the people that did not see a movie, that was 97 of them, and that saw the movie were 63 of them. So when it says a person saw a movie, given that they were a man, you only look at the man's line, and you say saw a movie, given it was the guys. Did not see a movie, given it was a woman. Did not see the movie, given it was a woman.